Now let's talk about the architecture itself. If you're used to the non-CDB architecture, you can think of a non-CDB database as a single entity. Now we know that within that entity, there are different subcomponents. There's schemas, there's table spaces, and so on. But what we're going to focus on here is that it will have its own memory associated with it. It will have its own set of background processes to run everything, your lock manager, your PMON, SMON, and so on. And then it will have its own set of files, your system and sysocs table spaces, your user table spaces, and so on. It will also have a set of redo logs, archive logs, flashback logs, and so on. If you have multiple databases on a system, that means you have multiples of every single one of these. You have multiple SGAs allocated for every one of those databases. You have multiple sets of background processes running, and of course, multiple sets of files, one for each database. And what this means is that even if one of those databases is completely inactive during some point of the day, maybe it's only active during business hours, or maybe it's only active at night when you're running batch processing, it still has that SGA associated with it unless you're shutting down and starting up databases all day long. Well, in the multi-tenant architecture, we get some economies of scale here because you start with a container database. That's your backplane of kind of in-database virtualization for Oracle Database. And the orange pluggable database that you see depicted there, that's our PDB seed that we use for provisioning. All the other pluggable databases are what we'll call application PDBs. And you can have many of them, as we saw, up to 252 application PDBs in an on-premises commodity hardware situation. So now, yes, you have your memory, you have your background processes running this container database, you have the sets of files, both the system and sysocs for every one of these databases, and you have one set of redo logs, for example, you have your set of flashback logs. But then as you add these application databases, you still have one set of memory, you have one set of background processes. And when this is sized for, in this case, 8 pluggable databases, what you're going to find is that the sum total of the memory needed to run those 8 PDBs is going to be a lot less than if they were 8 individual non-container databases. And that's because your individual non-CDB has to be sized for your peak processing load for every one of those databases. Whereas in your multi-tenant environment, you're generally going to find that when the first PDB is at its peak, maybe the 7th one is at its nadir of processing, and you can take advantage of that and size it. Generally, maybe start with a 30% less memory for your total SGA than you would as non-CDBs. Now, of course, you'd want to size it based on testing and knowing how your workloads interact, but you can generally get some really good hardware savings out of this. And on top of that, you get the ability to manage many as one in this architecture. You can back up all of these databases with one RMAN command, yet you can still restore individual databases to a single point in time, depending on your needs. So it gives you that economies of scale for managing databases as well as for using hardware. One of the ways we achieve that ability to manage many as one is that multi-tenant introduces a new layer of views in the container database. We're all used to, for example, user tables, which is all the tables owned by you as a user, all the tables that are visible to you as a user, and then DBA tables, which only those with DBA access would be able to see all of the tables in an individual database. Well, in a CDB environment, we introduce the CDB level of views where you would have CDB underscore tables, and that would list all of the tables in the entire container. Now, every one of those individual PDBs has its own namespace. So you could have the schema Scott with the table tiger, good old Scott.tiger, in every one of those PDBs. So in order to make this clear in the CDB views, we add a con ID column. That means container ID. If you're in a non-CDB, the con ID column is going to be 0. But if you have a container database, then the value for the container ID is 1 for the CDB root, 2 for the PDB seed, and then 3 up to 4098 for the individual PDBs. So that means that every instantiation of Scott.tiger in one of those PDBs will have a different container ID associated with it. So you can see the entire view with the CDB tables view, but yet you can also then tell which table belongs to which pluggable database. I mentioned that you can have economies of scale in managing pluggable databases in a multi-tenant environment. And one way to do that is just in the way you manage and run your scripts that you have to run against these pluggable databases. To run a script against multiple PDBs, what you want to do is use catctl. It's a Perl script that is built specifically to run SQL against multiple pluggable databases in a container. So let's just say that you had a script that you use for monitoring all of your databases. It's maybe looking at free space or something like that. And you want to run this periodically and watch to see whether anything is getting tight on a particular table space or maybe even on disk space, who knows? Well, you could do that with a SQL script in catctl and run that one script just once to get the results for all 8 of your pluggable databases in this case. So again, that manage many as one allows you to do so much more with your DBA resources that you have available that maybe you as an individual or it may be you as an organization.